Hey, what's up guys? Today we are going to learn 14.3, the Pythagorean Theorem. The Pythagorean Theorem. Okay, so this is pretty easy, but before we begin, I want to teach you guys the concept of the Pythagorean Theorem first. So take a look at these two pictures here. So a long time ago, when people were trying to count distances, they were like, oh, okay, this is easy to count. I know what this distance is. This is 1, 2, 3. So they were like, oh, this is 3 units up. Over here, when they saw this, they were like, oh, I know what the distance is here too. It's 1, 2, 3, 4. So that's going to be 4. Easy. But when they got to maybe a problem like this right here, and they were asked to find the diagonal distance, like this, from here to here, a lot of people were confused. They didn't know what this distance was. So along came this guy named Pythagoras, and he's all like, oh, I think I know how to figure this out. This is my picture of Pythagoras here. He looks like a wizard, like that. He's like, yes, I know what to do. Easy stuff. He saw that if you made this into a right triangle, right, a right triangle, I'm going to make a right angle right there. And I'm like, okay, you can make this into 3. You can count this as 4. And this is what he did. He got the side of this triangle right here. He squared the side. He squared the side. So this is 3. So he made it into a square like this. He made it into a square. So what's 3 times 3? That's going to give you 9. There are 9 squares within here, right? And then over here, he's like, oh, he squared this side. 4 times 4, that gives you 16. So I'm going to make it into a square like this. There are 16 squares here. And if you were to combine all the squares in here, the 9 squares here, and the 16 squares here, you could actually fit them into this side right here. This side, and 9 plus 16, that's going to give you 25 squares, and it's always going to fit perfectly within, like that. See, 5 times 5, that's 25. So if I know that this whole area right here is 25, then that means that this side right here, this long length, this is going to be 5, because square root of 25 is going to give me 5. So the distance between here to here, this diagonal distance is going to give you 5. Okay, so that's what we're going to be doing today. We're going to be finding the diagonal distance of a right triangle. Now, before we begin, I kind of want to drop some vocab on you guys. So in a right triangle, that's what we're only going to be focusing on today. In a right triangle, this side right here, this is called the leg. Okay, and you can call this maybe like A or something like that, leg A. Over here, this bottom part, this is also a leg. You can call this a variable maybe like B. And in this length right here, I know a lot of students go, oh, is that the hand or like the head or something? No. This is called the hypotenuse. Hypotenuse. And a lot of times you'll see in textbooks, this is called letter C, right? The variable letter C. So this is the Pythagorean theorem. Here we go. So basically, you're going to get this leg, right? A, and you're going to square it. So I'm going to say it's A and then square it. Over here, you have this b, right? This b, and then you're going to square that. So that's b squared. If you add this square with this square, just like what we did here, we add this square and this square, 9 plus 16. That gives you this entire thing right here, this entire 25, right? So if you add them up together, that's going to give you this c, this hypotenuse length right here, c squared. So this right here is the Pythagorean theorem. A squared plus b squared is equal to c squared. You're going to see this everywhere in like textbooks and in your math class next year and in high school. A squared plus b squared equals to c squared. Okay, so let's apply this to a couple of different problems. Okay, here we go. Take a look at number 1. You see, I have this right triangle. Remember, Pythagorean theorem only works on right triangles. And I need to try to figure out what this letter C is, what this diagonal length is. Okay, so I know my A. A is going to be 5. It could be 12, but I'm just going to say it's 5. It's going to be 5. I know my B. That's going to be 12. And my C, I don't know what that is. Okay, that's what we're trying to figure out. So I'm going to write down the Pythagorean theorem. Here we go. A squared plus B squared is equal to C squared. My A squared is going to be 5 squared plus the 12 squared is equal to C squared. All right, you guys can use a calculator for this lesson, or you can just use your head. 5 times 5, 25. 12 times 12, 144. That equals to C squared. If you combine these numbers together, that's going to give you 169 is equal to C squared. If you want to try to find C, go ahead and square root both sides. This is going to cancel out. I'm going to do a little tornado spin here. So C is equal to 13, because square root of 169 is 13, which means that this diagonal length right here is going to be 13. From here to here, that's 13. Okay, We found the hypotenuse for that question. Take a look at number 2. We're gonna, whoops, I think I made a little mistake here. This should be 10 right there. Okay. All right. So for this problem, oh, look, I give you the hypotenuse. I tell you that the hypotenuse is 10. See, the hypotenuse is the longest side right here. I know this is 10. It's also across from the right angle. Okay. So I'm going to say that my A is 6. My B, I don't know what that is. I'm trying to look for my leg this time. I don't know what the hypotenuse is. And my C, this time it's given to us. That's going to be 10. Okay. So we can kind of use the Pythagorean theorem to try to figure out what the missing leg is. Okay, so here we go. A squared is going to be 6. So 6 squared plus B squared, I don't know what that is. I want to keep it as a variable. And then C squared, that's going to be 10 squared right there. 6 times 6, 36 plus B squared is equal to 10 times 10, that's 100. Okay, we're almost done. So we're going to subtract 36 on both sides. Okay, so minus 36 minus 36. So B squared is equal to, what is that, 64. Okay, once I have that, I'm going to square root both sides so I can get the B by itself. This will cancel out. So B is equal to, 8. So this number right here is going to be 8. The distance from here to here is going to be 8. So you can say this is 8. Easy. Okay, so let's do a harder problem. So this is going to be found in your homework. Okay, so this is a free answer for you guys. So in your homework, you're going to see a problem like this. There's a right triangle. One of the sides is 4, so I'm going to say this A is 4. B, I don't know what that is. I'm going to leave it blank. And my C, this is the hypotenuse. Okay, this is 12 and 1/3. Ew, fractions. I know it's not that hard. Okay, I'll do it with you. Here we go. We're going to go A squared plus B squared is equal to C squared. I know my A, that's going to be 4 squared. My B, I don't know what that is. Leave it as a variable. And then my C squared is 12 and 1/3 to the second power. Okay, so let's do what we know. 4 times 4 is 16. B squared is, I don't know, just B squared. And 12 and 1/3, well, we can change this into an improper fraction. So 12 times 3 is 36 plus 1, that's 37. So this is 37 over 3. Now, if I do 37 over 3 times 37 over 3, because, we're squaring it, that's going to give us 1,369 over 9. Because 3 times 3 is 9. So I'm going to write 1,369 over 9. Hopefully you guys are using your calculators for this. Okay, once I have this, I need to get B squared by itself. So I'm going to subtract 16 here, subtract 16 here. So you guys all should know how to subtract fractions. I'm not really going to go through the process because by now you should know how to do that. So 1,369 over 9 subtracted by 16, that's going to give you 1,225 over 9. Okay, now I need to square root both sides. So I'm going to square root here, square root here. This will cancel out. So B will equal to square root of 1,225. That's going to give you 35. And square root of 9, that's going to give you 3. So that's the answer. It's going to be 35 over 3. But we can write this as a mixed number because right now it's improper. So that's going to give you 11 and 2/3. Yay! So this leg right here, this B, is 11 and 2/3. That's the distance. So just to kind of wrap things up, for the Pythagorean theorem, basically you're going to do this. This dude named Pythagoras, he got one of the legs and he squared it. He got the other leg and he squared it. And then he mushed both of these squares into this humongous area right here. So that the formula is A squared, right, the leg, plus another leg squared is equal to C squared. And just to remember, the hypotenuse is always going to be the longest length and the side that's going to be across from the right angle. Okay, hopefully this was helpful. I'll see you guys in the next video.